Okay, here we go. So remember that you guys are writing a quiz today on factoring, but we are going to start by reviewing factoring. So then pay attention to what we're doing. It's going to help you on your quiz that you guys are writing today. Tomorrow we'll go through the two chapter 5 quizzes. You wrote 5.1 already, so now we'll go through that quiz as well as the one you guys are doing today. You'll also have time tomorrow to continue to work on your review assignment, which you were given on Wednesday for those people that were here, keen, because that will be due for marks on Wednesday as well when you guys write your first exam on chapters 4 and 5. So if you weren't here on Wednesday to get the review assignment, you need to get it from me after the notes today. Okay? So again, we're going to start by doing some reviewing for factoring. Pay attention, copy everything down. This is going to help you on your quiz today because you're writing a quiz on factoring after we're done this lesson. So, some steps to follow. You're just going to be asked to factor a polynomial fully. And remember, on the quiz or on the test, if you're asked to factor a polynomial, it will be factorable. Okay, so you won't get any that are not factorable on your quiz today or on your test on Wednesday. But the first thing you always look for is a common factor, a greatest common factor. And if there is one, you remove it from each term by dividing. When you're factoring out a common factor, your common factor will be written down first, and then you'll have one set of brackets. And to determine what goes inside that brackets, you divide each term by the common factor. If there are 4 terms, check to see if there are any like terms that can be combined. If not, you try it by grouping. So that's where you group the first 2 and the last 2 together and take out a common factor from each group. We'll see some examples like that today. If the polynomial is a trinomial with a leading coefficient of 1, that's where you look for 2 numbers that multiply together to get the coefficient of the last term and add together to get the coefficient of the middle term. So we did that. If the polynomial is a trinomial and the leading coefficient is not 1, we use the method of trial and error or inspection to factor. If there are only 2 terms, check to see if it's difference of squares. And also don't forget about perfect square trinomials. So we will see examples of all those here today. And this is what your quiz will be based on as well, just factoring different polynomials. So for that first one, remember the first thing you always look for is a common factor. The common factor, remember, is the largest term that divides evenly into all of the terms. Look at the coefficients first. There's 6, 10, and 14. Those are all divisible by 2. Your common factor will involve the number 2. Now check the variables. There's at least one m in each term, and the smallest power of all those m's is in the second and third term. It's m to the 1 or just m. There are also n's in all 3 terms, and the smallest power of n is the n in the first term, which is n squared. That is your greatest common factor. To get the other factor, you divide each term by that common factor. 6 divided by 2 is 3. M squared divided by m is m to the 1. N squared divided by n squared cancels. So in the bracket, you'll have a 3m. Then, negative 10 divided by 2 is negative 5. When you divide m by itself, they cancel. N cubed divided by n squared is n to the 1. Remember, when you divide powers with the same base, you subtract the exponents and keep the base the same. Then 14 divided by 2 is positive 7. You need signs in between these terms. And that sign is determined by dividing the coefficients. When you divide the m by the m, they cancel. N to the 6 divided by n squared, again, subtract the exponents. 6 take away 2 is 4, so it becomes n to the 4th. Inside the bracket is a trinomial, but it's not factorable. That one is done. Took out a common factor of 2mn squared. That's your first factor. The second factor is what's in the brackets. That one is done. Right? Question 2. That's a trinomial. There's no common factor. The coefficient of the a squared term is 1. So we will factor this by dropping two sets of brackets, because if trinomials are factorable and then there's no common factor, the factors are binomial factors. And the front terms of each binomial must multiply together to get the a squared. That's why they're both a's. And we're looking for two numbers that multiply to get negative 12 and add to get negative 1. Because they multiply to get negative 12, their signs have to be different, one positive, one negative. And because they add to get negative 1, the bigger number must be negative. Negative 4 and positive 3 are the factors. Negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. Now remember, you can always check these by actually multiplying using the distributive property. This is our check. You should never get your factors wrong, because if you multiply them out, you need to get what you started with. So a times a is a squared, a times 3 is positive 3a, negative 4 times a is minus 4a, and negative 4 times 3 is minus 12. You got the a squared, you got the minus 12, 3a take away 4a is negative 1a, which is the correct middle term. We have just shown that our factors are correct. Remember, factors are things that multiply together to get what you start with. Right? Number 3, there are two terms there. There's no common factor. So you check for difference of squares. So there's a minus sign in between the terms, and they are both perfect squares. You can take the square root of both terms. So they are difference of squares. When you factor difference of squares, you'll get two binomial factors. To get the terms, the square root of 36x squared is 6x. That goes in the first position of each binomial. And the square root of y squared is the letter y. One's a plus, one's a minus. There's your factors, which you can check again by multiplying using the distributive property. So when you multiply, you'll get the 36x squared. 6x times negative y is negative 6xy, and 6x, just need to check this. This should have been a plus y, sorry, not a negative y. So positive y times 6x is positive 6xy, and negative times a negative y is positive y squared. So you see you got the 36x squared at the start, you got the y squared at the end. The 6xy's cancel because one's a negative, one's a positive. That leaves you with just the original expression. So we have just shown that our factors are correct. They do work. Okay. Question 4. Again, look for a common factor. And in this case, there is a common factor of 7. And if you take it out, you'll get x squared plus 9. X squared plus 9 is a sum of squares, not a difference of squares. You cannot factor a sum of squares. This one is done. We did factor it. We took out a common factor of 7. And that gave us a second factor of x squared plus 9. So we did factor it by taking out a common factor, and that's all we could do. Question 5. Again, look for a common factor first. There's a common factor here of 2b. Each term is divisible by 2b. So our common factor is 2b. To get the factor inside the bracket, we divide each term by 2b. When you divide the 2's, they cancel. B cubed divided by b to the 1 will give us b squared. Negative 20 divided by 2 is minus 10. B squared divided by b is just b. And then 48b divided by 2b, well, 48 divided by 2 is positive 24. And when you divide the b's, they cancel. So there's your first step. We took out a common factor of 2b. And now we look at the trinomial that's left inside the brackets. That can also be factored. We can also factor that. So this is one of those trinomials where the number in front of the b squared is 1. So this is one that we do by finding two numbers that multiply together to get 24, add to get negative 10. The front terms multiply to get b squared, so they both have to be b's. And the numbers that work here would be negative 6 and negative 4. 12 and 2 will not work. Their signs have to be the same to get a positive 24. And if you use a negative 2 and a negative 12, they add to get negative 14, not negative 10. You must use negative 6 and negative 4. They multiply to get negative 24, or positive 24, I should say, and they add to get negative 10. So there is what we are saying our factors are, and we'll check this by multiplying. First, I'd multiply the 2b by the b minus 6. That'll give us 2b squared, take away 12b, which is then multiplied by b minus 4. And now we'll do the remaining check by multiplying out the brackets using the distributive property to make sure we get the original polynomial. So 2b squared times the b is our 2b cubed. 2b squared times negative 4 is negative 8b squared. Negative 12b times b is minus 12b squared. And negative 12b times negative 4 is positive 48b. So we've got the 2b cubed at the start that we needed. We've got the positive 48b at the end that we needed. And when you combine negative 8b squared, take away 12b squared, that's negative 20b squared. We've got everything we needed. We have just shown that our factors are correct. These are the factors. There are 3 of them. We first took out a common factor of 2b, and then we have 2 binomial factors. That one is now done. Okay, Keaton, you with us? Looking at number 6, there is no common factor there. It's a trinomial. The number in front of the x squared is 1, so if there are factors, there'll be binomial factors. What are the front terms multiplied to, Keaton? You need to put your phone away, okay? Put it away. Thank you. The front terms multiply to get x squared, so they both have to be x's. And now we're looking for two numbers that multiply to get negative 36 and add to get positive 5. Because they multiply to get negative 36, their signs have to be different. They're going to add to get a positive 5, so the bigger number must be positive. There's the factors. And that one is done. Okay. X minus 4 is not difference of squares because you cannot take the root of x. That would have to be an x squared, not an x. That one is done. So on the next page, number 7, there is a common factor here of 3 to take out as a starting point, which will give you a squared minus 8a plus 16. All 3 terms are divisible by a, so that's your common factor. To get the other factor, you divide each term by the common factor. Now that trinomial is factorable. It's actually a perfect square trinomial because the first term is a perfect square and the last one. But remember, that's only the first step to determining whether it's a perfect square. But if we start with that first, the square root of a squared is a, the square root of 16 is 4. Remember the other part of this, you got to multiply these two together and double. And if it gives you the middle term, then it is a perfect square trinomial. A times 4 is 4a, doubled is 8a. You do get the right middle term. So that tells us that it is a perfect square trinomial. Because it's a minus 8a, it has to be a minus 4 all squared. If you did this the way we did the last one, you're looking for two numbers that multiply to get positive 16, add to get negative 8. Negative 4 and negative 4. You're still going to get a minus 4 and a minus 4 as the two binomial factors. So whether you do it by recognizing it's a perfect square trinomial or go back and do it the way we did before, doesn't matter. Question 8, there are 4 terms there. There are no like terms to combine. There is no common factor amongst all four terms. So this one we will do by grouping. And remember to do by grouping, you group the first two terms together and the last two, but you also remember you need to have a plus sign in between the brackets. So I added that plus sign in between the brackets. I kept all the signs in front of the terms the same. You need a plus sign in between the brackets. And then you take out a common factor out of each group. The first group has a common factor of 2m. And if you take that out, if you divide each of those terms by 2m, you'll be left with x minus y. So common factor of 2m in the first group. The second factor is x minus y. Now we need to take a common factor out of the second group, so we also get x minus y inside those brackets. And because of that, you need to take out a common factor of -3, which will give you a positive x and a minus y. Because you need the same thing in both brackets now. And we have that. Right? We got two terms here. Each term has a factor of x minus y in it. That is our common factor. X minus y, and our other factor would be what you're left with when you divide each of those terms by x minus y. You'll be left with the 2m from the first term and a -3 from the second. So there's your factors. And you know, if you check this using distributive property, the x times the 2m is 2mx, which is that first term. The x times the -3 is -3x. The negative y times the 2m is minus 2my. That's that term right there. And the negative y times the -3 is positive 3y. That's that term right there. So it checks if you multiply it out. Number 9. There is no common factor there. This is a trinomial, and the front term has a coefficient of 6, not 1. So this is one of those ones that we need to do by inspection or by trial and error. The front terms multiply to get 6m squared. So I would start with 2m and 3m. If I can't make those work, then I would try 6m and 1m. But normally we start with the ones that are closest together. The last terms have to multiply to get positive 10, so that I can be 1 times 10 or 2 times 5. Again, I will start with the ones that are closest together, 2 and 5. However, I wouldn't put the 2 with the 2m. We talked about that before. If we put the 2 here with the 2m, there'd be a common factor of 2 amongst those two terms. But if there was, there would have been a common factor of 2 at the very beginning, and there wasn't. So the 5 must go with the 2m. The 2 must go with the 3m. Because they multiply to get positive 10, their signs have to be the same, and they add to get negative 19, which means they both have to be negative. So now we're going to check that by multiplying. Right, the 2m times the 3m gives us our 6m squared. The -5 times the -2 gives us our positive 10. The outer products will be -4m, the inner products -15m. -15m take away 4m is -19m. Those are the correct factors. We didn't write down our check, but we did it. We just did it verbally. We didn't write it down, but we just did it. It checks. Question 10. This looks like it might be a perfect square trinomial because the first and last terms are both perfect squares. And remember, we said this is often quite helpful, especially when the numbers are large, like they are here. Whoops. So remember, to check for a perfect square trinomial, both terms must be perfect squares, the first and the last, and they are. The square root of 4a squared is 2a, the square root of 49 is 7. But that's only the first step. Remember the second step? You got to multiply those two together and double, and if it gives you the middle term, then it is a perfect square trinomial. Brock, stay with us, please. Thank you. So 2a times 7 is 14a, doubled is 28a. So it is a perfect square trinomial. And because the middle term is minus 28a, the sign between the 2a and the 7 is minus as well. There's your factors. 2a minus 7, 2a minus 7. There's your factors. Remember, Brock, this stuff's going to be on the quiz, right? So this is review for your quiz that you're going to write here. Okay. Number 11. Remember, first step always look for a common factor. There is a common factor here of 5n. Both terms are divisible by 5, and each term has at least one n in it. So that's your common factor. To get the other factor, divide. Divide all the terms by the common factor of 5n. 45 divided by 5 is 9. N cubed divided by n is n squared. Negative 5 divided by 5 is minus 1. When you divide the n's, they cancel. P squared divided by no p stays p squared. So there's your first step. Common factor of 5n. And that binomial inside the bracket is a difference of squares because it's a binomial, minus sign in between, and both terms are perfect squares. So remember, when you factor a difference of squares, you end up with conjugates. They are the binomials with the same two terms, just with different signs in between. When you factor a difference of squares, you get two binomial factors, and they are conjugates. The square root of 9n squared is 3n. So that goes in the first position of each binomial. The square root of 1p squared is p. That goes in the second spot of each binomial. One's a plus, one's a minus. There's your factors. And you can always check by multiplying out if you're not sure. Remember that. Number 12, that's a trinomial, and there is a common factor. Your common factor here would just be the letter m and n. The coefficients don't have a common factor because the middle number there is 5. That's a prime number. So to get the other factor, you'll divide each term by mn, which will give us 6m squared plus 5m minus 4. So there's our first step, common factor of mn. Now, the trinomial that's left inside the bracket, we're going to see if we can factor it as well. And because the front number is 6m squared, we have to do it by guess and check. Right? We cannot use those steps of finding two numbers that multiply to get negative 4 and add to get 5. It doesn't work because the front number, the number in front of the squared term, is not 1, it's 6. So the front numbers here in these binomials multiply to get 6m squared. We will try 2m and 3m first. And if we can't make those work, then we'll try 1m and 6m. The last numbers have to multiply to get negative 4. It's either 2 and 2 or 1 and 4. But it will not be 2 and 2. You would not have a 2 with the 2m. We talked about that. So the only thing that might work is if we have a 1 there and a 4 there. They multiply to get negative 4, so their signs have to be different, one positive, one negative, and they add to get positive 5m, which tells me probably that the bigger number would have to be positive and the smaller number negative. Now let's check that. The 2m times the 3m gives us a 6m squared. The negative 1 times the 4 is negative 4. The outer products will be 8m, the inner products minus 3m. 8m take away 3m is positive 5m. So we have the factors. It checked. I didn't write out the check, but we did it verbally, showing that when you multiply out those two binomials, you will get this trinomial there. Right, question 13. There is no common factor amongst all 4 terms. There are still 4 terms there, though, so this is one of those grouping ones. So remember, you group the first 2 and the last 2 together, but also remember you need a plus sign in between the brackets. And then you take out a common factor out of each bracket. The common factor out of the first set of brackets would be 2x squared. And that would leave us x minus 3. You need to take a common factor out of the second set so you also get x minus 3, which means you need to take out a common factor of negative 5. That will give you the x minus 3. So again, we got 2 terms here. There's the first term, there's the second term. Both of those terms have a factor of x minus 3. That is our common factor. To get the other factor, you'll divide each of these terms by the x minus 3, which will give us 2x squared, take away 5. So there's your factors. Question 14. There is a common factor there, a common factor of 2, which leaves you with m squared minus 1. Right? To get that m squared minus 1, you divide each of those terms by the common factor of 2. And m squared minus 1 is a difference of squares because it's a binomial. There's a minus sign in between, and they're both perfect squares. The square root of m squared is m. The square root of 1 is 1. One's a plus, one's a minus. I'm going to check this one. The last couple of ones we verbally checked. We didn't do it by writing it down. I'm going to do it for this one. So first you're going to multiply the 2 by the m plus 1. That'll give you 2m plus 2. And now, to multiply the binomials, we use distributive property. So that'll give us 2m squared minus 2m plus 2m minus 2. The minus 2m and the plus 2m cancel. You're left with 2m squared take away 2, which is the original polynomial. 2m squared take away 2. So we've just shown that our factors are correct. The only way you'll get factoring questions wrong if you don't take out the greatest common factor, because you can always check by multiplying. Okay? So your quiz that you're going to write now is going to be based on the stuff that we just did. So hopefully you were paying attention, because the review should have been helpful for you. So you're going to do the quiz, hand it in, and then you get to work on the review assignment that you guys got on Wednesday. If you weren't here Wednesday, I'll give you a copy today, because this will be due on this coming Wednesday, which is when you have your unit exam. Tomorrow we'll go through both Chapter 5 quizzes, and then you'll have the rest of the class to work on the review assignment. If you can do everything in this review assignment, you'll do well on the test tomorrow or Wednesday. This will tell you what you remember, what you don't remember, what you need to study and get practice on by going through this review assignment. So make sure you get it done before the test on Wednesday. It's the best thing you can do to get ready. Okay? Did you have a question, Brock?